We're going to play with some liquid nitrogen today, and we're going to start with this device here. This is a Dewar, and it's like a giant hydro flask. Multiple layers in there to keep it refrigerated. We're going to pour it into here, and we can play with it. So I wanted you to see how it looks. It looks a lot like water. So you can pause it. As you can see, it looks just like water, just like water. We're going to put a couple of balloons in there and see what happens. Balloons are made out of, we blow in there mostly nitrogen and oxygen, and the air loses kinetic energy, and it becomes very much like liquid nitrogen that it's in. Look at it just swimming in there like it's water, but it's super cold. And we just take it out. Watch them grow. All right, now we're gonna put a little bit in here just for fun to take one of our flowers and see what a beautiful little flower that is. We're gonna stick it in there and get it a little bit cooled, and then we'll just break it on the table. All right, we're gonna take some saltine crackers here and cool them down just a little bit, and then let them eat them. You can breathe out through your nose, through your mouth. All right. What we have here is a device that will run electricity through these copper coils, and when it does that, it'll induce a magnetic field that when you put another coil near it, and like this case, this aluminum ring, that will then make the electrons move in this ring, which in turn makes a magnetic field that opposes the one that's here, and then it'll launch it. So it'll work basically like this, which launches really nicely. But when we cool it down and we put it into liquid nitrogen, it reduces the resistance of the electrons, and they flow much more freely, which means they create even a greater magnetic field, and it'll go a lot farther. It works very similar to the way that phone chargers and so forth work. So let's take that out of the liquid nitrogen, and I'm gonna put this device on the floor, and we will see that this thing's gonna fly. Okay. All right, so the next thing we're going to do is we're going to put some liquid nitrogen into a bottle and put the lid on it, which is going to be then turning from a liquid into a gas very rapidly that takes up much more space, and it's going to explode. I don't recommend that you do this at home. It should be done in a very safe way. All right, here we go. All right, now we're going to do a larger bottle. The next thing we're going to try to do is we're going to put some liquid nitrogen into this vacuum chamber. We're going to use the vacuum pump and we're going to suck the air out to reduce the atmospheric pressure. By so doing, we're going to try to make it evaporate more quickly, which will take energy from the system, but also we're going to reduce the pressure so that we can reach what's called the triple point. Under normal atmospheric conditions, nitrogen freezes, or I should say is a liquid, at negative 196 degrees Celsius or minus 320 degrees Fahrenheit. It will turn into a solid just about 15 degrees cooler at minus 209, and if we can lower the atmospheric pressure down to almost zero, we can turn it into a solid, liquid, and a gas at minus 210 degrees Celsius. That's just 63 degrees Kelvin. So this is pretty cool. So let's give it a try. Alrighty, so let's set the lid to the side. Alright, let's take a look at what's happening inside the tank, and we see that the liquid nitrogen is boiling, and it's getting colder and colder. Look there in the middle, we see some ice, I should say nitrogen crystals forming, doing quite the dance. Alright, you will see that there are some crystals forming on the outside of the cup. Only the nitrogen frost. Just took the lid off, took the pressure off, and the nitrogen is not boiling. It's just sitting there. It's really cold, really, really cold. The frost is staying on the outside of the cup. We put a banana in here, and it's just kind of cool to see the vent of the container. All right, we put a banana in here, let it sit for a little while. We'll take a nail. Ah. Pretty hard banana. This container has about 2 centimeters of liquid nitrogen in the bottom, evaporating to form some very dense cold nitrogen gas. The bubbles are landing on that gas about 3 or 4 centimeters above the liquid nitrogen, and then freezing the bottom half into a hemisphere of the bubble. And here we scoop out above the gas this frozen bubble that's just in there, and now as it comes out you can watch it melt. See it melting slowly around the edges. Alright, that looked pretty good. As the bubbles rain down on the nitrogen gas, they're freezing into hemispheres and easily being picked up by our fingers and watching them melt as they come out. Alright, so I'm wearing all the safety gear because I've done this before and blown up the bottle right next to my head, so I'm going to wear a little more safety gear. We're going to give this a try. We're going to put some liquid nitrogen in here and turn the bottle over and see if she goes. All right, let's try again. This time let's vent a little bit on the side of the funnel, see if we can get a better launch. I'm going to put a little balloon in here. It's actually floating on the gas and not on the liquid nitrogen. As it cools down, of course, it'll fall down. We're going to put some liquid nitrogen into some hot water. All right, tell me when.
When?